Here's what I would expect you to have in your lab notebook. Again, you have the title. I just use BB to abbreviate. I know these aren't BBs, but it's ball bearing. So we have a large mass and a small mass. Those are the only masses you're going to have. These, obviously, you can use grams if you wish, or you can use kilograms. It doesn't matter as long as you use the same label, same unit the whole time. I've obviously just made these numbers up. So your instructions will tell you that you're going to do large, 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 small, small, large, and that should be small, small. I had a mark over it. And then we're going to do a large, large that's a little different. So my second velocity is 0 for everything except for my last one. On my last one's the instructions, we're going to run the balls together going from both directions. So on my made up numbers, I said I found my first velocity was 900 and they were both mass of 500. So before contact, and again, as always we do, the row 1 we're going to show the work. My P, that's my momentum before, is the formula is M1V1 plus M2V2. So it's 500 times 900 plus 500 times my 0 because it's not moving. So I got 450,000. My units don't make much sense here because I'm doing my velocity as pixels per second, but if I was using standard units it would be kilograms meters per second. Afterwards I now have two objects moving, and in my made up data I said the velocity was 300 for my first object. Again, the prime is not the derivative. The prime just says this is the velocity of the same ball that had this velocity. So I went from moving at 900 to 300. So my first ball slowed down. My second ball obviously went from 0 to 625, so it sped up. So when I combine those, 500 times 300 plus 500 times 625, I get 462,500. If we had a system that had no outside forces and we could measure perfectly accurately, in other words, if friction was truly not mattering at all, these would be identical. Okay? As it is, in my made-up data, I have a percentage difference of 2.8%. So you need to show your data for one row. You have to show your work for the first row. After that, you can, if you want to show it, that's fine. If you want to just punch on your calculator, you can. Now, on this last row, when you get the instructions, one of these velocities has to be negative. It doesn't really matter which one you make negative, but one of them has to be negative because they go in opposite directions. And so you have to pay attention to the signs to get this to work on the last row. Good luck.